Jai Janendra, Namaste and welcome to my channel. Today we are going to solve the 82nd question of the problem solving series and the 7th question of the topic linked list. The difficulty level for this question is medium and this question has been asked in Google, Amazon, Microsoft, Meta, Adobe and Apple. Linked list cycle 2. In the previous question, the question was to detect the linked list, detect cycle in the linked list, and here in this question we need to return the first intersecting point of the starting point of the cycle. Okay, so we need to return the starting point of the cycle where the cycle began. Okay, so it first we need to determine whether the cycle exists or not. Okay, and if the cycle exists, then only we can say find out the starting point. If the cycle doesn't exist, then how we will get the starting point, right? So here actually I wrote the name wrong, didn't change the name of the function. English, it should be, I don't remember what was the name. In starting points, this node starting point, starting cycle point. Okay, it should be, this name should be better. Okay, so let's look at the example. So 1, 2, 3, 4 and 2. Okay, so we know the tortoise and hare algorithm, we need to find the cycle in the linked list in order 1 space and order n time complexity. So here if we run this slow and fast, okay, if you have not seen the previous question of detecting cycle in the linked list, then please go and watch it. So here for you, I'll discuss it. We'll have two pointers, slow and fast. We'll move slow pointer by one step and fast pointer by 2 steps. So if there is no cycle, then fast pointer will come to null, or fast next will come to null and will terminate and will return there is no cycle. And in this case, if there is no cycle, we will return null because there is no starting point, right? So if there is no cycle, then the starting point would be null. But if there is a cycle, then this will not come to an end because after 4 every time it would go to 2, 3, 4, right? So now how do we determine here? So we know that the starting point of the cycle is 2. It starts from 2, 3, 4, 2, 3, 4, it will return. So 2 pointer is the starting point. Here there is no starting point, right? Since there is no cycle. So there is no starting point of the cycle, so we will return null. Now how do we do this? So first we need to determine whether there is a cycle or not. So to determine whether there is a cycle or not, what we'll do, we'll just write this code of determining whether there is a cycle or not. So what we did, list node slow is equal to head, fast is equal to head. Okay, so we take this and then while fast not equal to null and fast next not equal to null, and we run slow is equal to slow next and fast is equal to fast next ka next. At any point, if the slow is equal to fast, we know that there is a cycle. So if there is a cycle, we write int cycle is equal to 0, right? We define this, and if there is a cycle, then we will make cycle equal to 1, right? And if there is a cycle, we will make cycle is equal to 1, and then we will break. We'll break of the we make cycle is equal to 1. If cycle is equal to, we can just give it break here itself. Okay, so it will break from the loop, right? So if cycle is equal to 0, then we can return null because there is no cycle. But if cycle is equal to 1, then we need to find the starting point. How we will find the starting point? That is the thing. So there is an algorithm by which we can find the starting point of the cycle in the linked list, and that algorithm, first I'll write, then I'll give the proof of the algorithm. Okay, first you need to know what is the algorithm. So when we find the starting point, so here, for example, here then slow is equal to fast, right? So like for example here slow is slow and fast both are at 1. So slow moves here 1 step, fast moves here 2 step, right? Then slow moves here 1 step, fast will move 3 to 4, 4 goes to 2 here. Then slow moves 1 step and fast moves 2 step. And when we see that both of them are same, like here, we get cycle is equal to 1 and we break. Okay. Now we have slow and fast both at the same point, right? The algorithm is when you find the cycle, then what you do, while, so we have head at the beginning. So what we do, while head is not equal to slow, right? We move head is equal to head next and slow is equal to slow next. And when we see that the head and slow are same, are equal, so this will break and then we will return head or slow, and that would be the starting point of the list. How? Let's check this example. Here this was 4 and this slow is here and head is here. So head and slow are not equal now, right? So we move head 1 step here and slow moves here. Head and slow are pointing at the same point, and head and slow is the starting point of the list, right? So this is the algorithm. The time complexity is same, just order of n of finding the cycle in the list, and then highest order of n here also. So order of n is the time complexity and there is no space complexity. Space complexity is order of 1. Now this interesting point. How does this algorithm work? What is the proof of this algorithm? I'll try to explain the proof of the algorithm. So let me just rub it so that I can take an example and try to prove how this actually works, right? So say we have a linked list 1, 2 and 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 3. Okay, this is a linked list which has this cycle. Okay, now we have this head here and slow and fast is here. Okay, slow travels here. Slow travels 1, slow comes here, then fast comes here, then slow comes here, and then fast comes here. So slow enters the starting point of the linked list and fast is here. So if you consider that this is a length of L1, okay, then how much, if S has crossed L1 till now, which is the starting point's length, that time fast crosses 2 into L1, right? So this is L1 and this is also L1 because this and this are same, right? The length is same. The L1 is equal to 2 distance, and L1, this L1 also 2 distance. So when slow travels L1, this is already L1 which fast has already traveled, and since fast travels double of S, so this total length is 2 into L1, so this length is L1, right? I think there is no doubt about this. So fast has traveled to L1 and fast is here, and slow has entered the loop. Now say what is the distance between S and F? If F has to move this much distance to reach where S is, but when F will move this much distance, that point of time S will also move, right? But when S and F will move, at one point F will cover the extra distance that they are having now. They will meet at one point, and then so for that they have to cover, S and S have to cover this extra distance. Say this extra distance is D. Okay, from here to here, this extra distance that f has to cover extra is d, right? So now when s will cover here this distance, s will move here 1, s will move here 1, then f will be moving here, right? Then s will be moving here, then f will be moving here, then s will be moving here, then f will be moving here, right? Then s will be moving here, then f will be moving here, and then s will be moving here, and then f will be moving here. So at this point, the f has covered the extra distance what s was having from it, right? So s has covered same distance and f has also covered this extra d distance, right? So at this point s and f has met, and we came to know that there is a loop in the list because s and f are same. Now here you see this distance what f has covered is actually this whole thing, okay, this whole circle. What is the length of the circle? Length of the circle is L1 plus D, right? This is L1 and this is D. So L1 plus D is there, right? This is the length of the whole circle. And then this F actually covers this this much length, but this double of length, this whole circle's length it covers plus extra length, but that F covers. But what does S cover? S covers here this S, the distance that S has covered is actually D distance. You can see here that this whole length is L1 plus D, and then when S moves, actually S moves here and meets at here, this length is actually 2. So S actually covers D distance, right? S actually covers D distance. From here to here, S covers D distance, and L covers 2D distance, double of this, right? And it meets here. So since S has covered D distance and here it is there, and this one total was L1 plus D, right? So this distance is actually L1 distance that is left to cover the whole loop. It has covered D distance. So here when S is there and head is, and this distance is also L1. So where they meet and where they have the distance from this meeting point in this loop, this is same. So when we move head to L1 distance and S to L1 distance, they meet at this point. So we have this algorithm that we have discussed. Okay, I hope you have understood the algorithm, the logic behind the proof of the algorithm. The algorithm I just wrote it and I just rubbed it. I think you would have understood that. The link to the question is given in the description. Please try it yourself and then come to my code walkthrough section. Here's the code walkthrough of the 82nd question, linked list cycle 2, where we find the starting point of the list in the LeetCode platform. I've already discussed the proof, you have seen it. So let's just look at the code. We find the loop here, if there is a loop, and if there is a no loop, then we return null, and we have while slow not equal to head, and we move this slow is equal to slow next and head is equal to h next, and when they intersect, that means that is the starting point. So let's submit this code. So it has been accepted. See also need the next video where I'll be explaining the 83rd question of the problem solving series, and these are the companies in which this question has been asked. You can see. Okay, Jai Jinendra.